Okay, so this is lesson number 8, present value of an annuity. Present value of an annuity is the amount of money that must be invested today at the given interest rate and compounding period in order to make regular annuity payments. So these types of questions are usually loans, okay, because the present value is the amount you owe right now, or they're questions about lottery winnings with what the money you have right now, as opposed to money you want to have in the future. So we have a slightly different formula for present value than we did for future value. Okay, for present value, it's PV equals R, which is still our regular payment, same as the other formula. But inside our brackets, we have 1 minus 1 plus I to the negative n divided by little I. So it's slightly different than the future value formula. The 1 is in front instead of behind the brackets, and the exponent up here is negative n. That's kind of the big difference. Okay, our variables are all the same though. R is the regular payment, I is the interest rate per compounding period as a decimal, and n is the number of compounding periods. So we're just going to do 3 examples using this new formula. Our first one, we have Simrat, who started to repay a student loan at $280 a month. His monthly statement indicates that he has 12 payments left, and the interest rate is 9.75% per year, compounded monthly. So if the bank lets him pay off his loan today, how much will he have to pay? So we can work backwards to find the present value of his loan using the present value formula. So we're looking for what the present value of his loan is. We know that his payment amount is $280. We know his interest rate is 9.75 monthly. And our number of compounding periods, they actually tell us directly in the formula, is 12 payments. So it's going to take him 1 year if he's paying monthly. So our n is 12. Okay, so if we use our formula, we substitute all of our values in. So 280 for R, 1 minus 1 plus I, to the exponent of negative n, all of that divided by I, and we put this into our calculator. So you can do this step by step. You can punch it in all at once if your calculator types. So what you should do is you should put this into your calculator and see if you come up with the same answer as me. So what the answer should be is $3,189.08. Okay, so if he wants to pay off his loan right now, he has to pay $3,189.08, which saves him a bit of interest, because if you take his $280 payments per month, if he spread that out over the year, it would take him actually more money than what he could owe the bank today. Okay, so just using the formula, substituting all your values in, and getting an answer. Another type of present value question would be something where we're trying to figure out how much money you should invest now to get back a certain amount per month or per year out of that account. So if Gerlene's going to university and her grandfather's going to deposit a lump sum of money into an account paying 5.5% that's compounded annually, okay, and he wants it so that Gerlene can make withdrawals of $5,000 every year for 4 years. Okay, so how much should her grandfather invest today so that she can get $5,000 a year for 4 years? So we can use our present value formula to figure out how much money he should invest today. Okay, so our payment amount is $5,000 because he wants her to be able to take out a regular payment of $5,000 from the account. Our interest rate is 5.5%. and the compounding period is annually. So we can divide this by 1, which gives us the same value back. And our number of compounding periods is 4 years times 1, because it's compounding annually, so n is 4. Okay, so we can substitute all of these values into our formula. So 5,000 for r, 1 minus 1 plus I, to the exponent of negative n, all of this divided by I. Okay, and if you punch this into your calculator, you should get $17,525.75. So if Gerlene's grandpa can get an interest rate of 5.5% compounded annually, he needs to invest $17,525.75 right now in order for that to be possible. For our last example, it's a little bit different. In this example, we want to provide an annual scholarship for 25 years, and a donation of $50,000 is being invested today in order to provide money for this annual scholarship. So what they want to figure out is how much can we afford to give every year as a scholarship if we're getting 5.5% interest compounded annually in this account. So in this case, we know our present value is $50,000. What we're looking for is how much we can afford to pay out as a scholarship every year. So we're actually looking for our regular payment. Our interest rate is 0.055, okay, and it's compounded annually, so we can divide that by 1, which gives us back the same value. And for our n value, this is our number of years, so we want to be able to give this scholarship out for 25 years, which means our n is 25, and again, it's compounded annually, so we would multiply this by 1, so it gives us back the same value. So when we have our formula, we're actually solving for r instead of solving for PV. So in order to isolate r, we want to divide both sides by this giant bracket. So what we're actually going to do to solve for r is we have our PV on top, and we're going to divide that by 1 minus 1 plus I to the negative n divided by I. Okay, so we're taking this whole bracket here, and we're just dividing both sides by that giant bracket. So if we substitute all of our values in, so our present value is $50,000. We have 1 minus 1 plus our growth rate to the negative n, and all of that divided by our I value. Okay, and this will give us how much they can afford to hand out as a scholarship every year. So when you're doing this on your calculator, make sure you're doing BEDMAS. So if you're doing it step by step, you would do 1 plus the growth rate, then to the exponent negative 25, 1 minus that, divide it all by 0.055, and then take your answer and do 50,000 divided by whatever you get for this giant bracket part at the bottom. The most important thing is that you don't want to round until the final amount, because it can really affect your answer if you round too early. So you should try punching this into your calculator. When you do, your value for R should be $3,727.47. So with this $50,000, they can afford to give a yearly scholarship of $3,727.47. So I'm sure they're going to round that down and give out a scholarship of $3,700 every year. Okay, so present value of an annuity is when you have the lump sum right now, or if you're trying to figure out what is the lump sum right now based on my payment.